Alright, so let's talk about the ambiguous case. When you use the law of sines and you're given a side-side angle. So when using the law of sines on a side-side angle triangle, you have to be careful about the number of solutions you could have. It is possible to have one solution, two different solutions, or no solution. This is why a triangle with side-side angle is called the ambiguous case. So, the ambiguous case test. To find it, first you're going to solve the first triangle if possible. Then you're going to take 180 degrees minus the first angle that you found. You're going to add the angle that was given and compare that sum to 180 degrees. Remember, you can only have 180 degrees in your triangle. So, if the angle that you find plus the angle that was first given add together to be 180 degrees or more, then that's not going to work. There will not be a second triangle. And so I'm going to show you. So I know that sounded really confusing, so let's go ahead and let's look at the cases here. Now they're nice. They told us what to expect, but we're going to pretend that we don't see that. Alright, so I'm always going to set up as if I'm going to have one triangle. So, for my first problem here in example 3, I'm going to go ahead and I'm going to use the space over here for my little setup. So angle A, angle B, angle C, side A, side B, side C. Fill in with what they gave us. And they didn't give us units for our sides, so we don't have to label the sides, but we do need to make sure we put the degree symbol. Alright, so I can see here that they gave a side-side angle. So that means I have a little thing I just kind of try to help me remember. It's side-side angle, look for second triangle. So I know that this one has the possibility of having a second triangle. So I'm going to go ahead and set up. If it is, I will fill it in. If it's not, I will mark it out. No big deal. And so go ahead and plug in the same stuff that they gave you, because they gave it to us. And no matter what our triangle or however many we have, it's going to be part of our triangle, if there's one that exists. Alright, so go ahead and do this, because this reminds me, hey, don't forget the second triangle. So what do you want to find first? Well, they gave us angle A and side A, so we can use the law of sines, and they gave us side C, but we don't know angle C. So let's use that. So we're going to take sine of angle A over side A, I'm just plugging in my numbers here, equals sine, we don't know angle C, so just put angle C over side C, which was 23. Just like what we did on the others, we're going to cross multiply and divide. So I'm going to do 23. Actually, you know what? I'm going to do the other one first because it's got my variables. So 47 times sine of angle C equals 23 sine of angle sine of 123 degrees. We're looking for C, but right now that sine of C is together. So we're going to divide by the 47. And so we got sine C is equal to all of this here. Now remember, when you're looking for an angle and you got to get rid of the sine, you can only do so by taking its inverse. So we're going to find angle C is going to equal the inverse sine of what we had on the other side there. So that 23 sine of 123 degrees over 47. And so just like what we did before, be careful when you type this in, because at 123 degrees, when you hit the sine button, it's going to open a parenthesis. So after the 123, you need to close it again. Alright, so let's put that in our calculator. And we're going to find that angle C is approximately 24.23 degrees. Now, the directions above say go ahead and finish it, but I'm going to stop here for a minute, and I'm going to just see, does that second triangle exist? And something I didn't do that I like to do normally is I put like a little prime symbol here, a little tick mark, so I can tell when I'm doing my work, which work goes to which problem. I try to color code, but I also do that, so I can see that that angle C that I circled is the angle C of the first triangle. Alright, now, so to find, here's the big thing, okay? So to find angle C prime, okay? Angle C of the second triangle, because they go together. Angle C, both of them. What it is the law of sine, or sine is positive, remember, in quadrants 1 and 2. So when we use our calculators by default, if it has a quadrant 1 answer, it's going to choose it first, okay? So it could be that we could also have a quadrant 2 answer that works as well, because quadrant 2 angles are still less than 180, so they're just obtuse angles that could be in our triangle. So we're going to take 180 degrees, and we're going to subtract the 24.23 degrees, the answer that we just found. And when we do that, I got 155.77 degrees. Alright, so I'm going to go ahead and write that in here. Now, to check and see if this triangle exists, I need to find angle B. So I'm going to go ahead and do that now. And so angle B prime is equal to 180 minus the other two angles added together. So 123 degrees plus 155.77 degrees. And so when I do that, let me see, I didn't write my answer down a minute ago. I got negative 98.77. Wait, can angle B be negative? No. And so what it is look, angle A and angle C are both obtuse angles. Can you have two obtuse angles in a triangle? No, those two angles together there are already or greater than 180. There's nothing left for angle B there. So that means that this angle, the second triangle does not exist. Now the first one still exists. We're going to go finish it. But because when I tried to find that third angle, it was negative, that can't be. Therefore, that second triangle doesn't exist. Now, let's go ahead and finish the first triangle, because it's still there. So, we need to find angle B. And so, let's do it the same way. So, angle B is going to be 180 minus the other two angles added together, and that was 123 plus the 24.23. And so we find that angle B is equal to 32.77 degrees. And then go ahead and use your law of sines to find side B. So again, I'm still going to use my information for angle A and side A. So we're going to take sine of angle A over side A. That's equal to sine of angle B over side B, which is what we're looking for. So we're going to cross multiply. So B times sine of 123 degrees equals 47 times sine of 32.77 degrees. Solving for side B, so divide by the sine of 123 degrees. And so side B is approximately, so we're going to put this in our calculator. And we should get 30.33. And so I'm going to come up here. So got all my pieces in that one filled out. My second triangle didn't exist. So I've got one solution. And here's all the pieces of it.